We are going to compare different sets of data using box plots. The box plot on your screen shows the distribution of two periods' final exam scores. So you have class period 1 and class period 2. Before we get started, I want to remind you of the different parts of a box plot. So this first point on a box plot represents the least value in the data set. That connects to the box, and this point where the whisker and the box connect is your first quartile, which is also called your lower quartile. The line inside of your box represents the median. So this point would be our median. And then the end of the box is your third quartile, which is also called your upper quartile. The last point in your box plot represents the greatest value in your data set. So now let's use all of this to compare our two sets of data. We can compare centers by looking at the median, since the median is the only measure of center that we have on a box plot. So for this period 1, when I come down, it looks like the median is at 85. So class period 1 has a median of 85. Class period 2, when I come down here, has a median of 81. So since class period 1 has a greater median than class period 2, I can say that they are typically scoring higher on tests or final exams than class period 2. So when I write my comparison, I would say class 1 has a greater median, which means these students typically score higher because a measure of center tells us about typical performance. Now, range and interquartile range can tell us about the spread of the data, which is how far apart the data sets are. To find the range, I know that I need to subtract the least from the greatest. So for class period 1, I'm going to find the least value. So it looks like that's right here at about 74. And then I also need to find the greatest value. So it looks like that's right here at 95. So to find the range, I'm going to subtract 95 minus 74, which will give me a range of 21. I'm going to do the same thing with class period 2. So for class period 2, I see that their least value is right here at 71. And the greatest value is right here at 92. So to find the range, I'm going to do 92 minus 71, which gives me a range of 21. So what we notice is that these both have the same range. So I'm going to say the ranges are the same or equal. And now I'm going to find interquartile range. So interquartile range can be found by taking the two quartiles and subtracting them. So just in case you don't remember, write yourself a note that interquartile range is Q3 minus Q1. So let's look at class period 1. Class period 1 looks like it has a third quartile that is right here at about 93. And it looks like it has a first quartile that's at right here at 79. So to find the interquartile range, I'm going to subtract 93 minus 79, which gives me an interquartile range of 14. For class period 2, when I look at Q3, it actually looks like it might be right here in between 90 and 91. So I can say that that's at about 90.5. Their first quartile looks like it's right here in between 76 and 77. So that would be 76.5. So when I subtract, I'm going to do 90.5 minus 76.5. And when I subtract those, I get an interquartile range of 14. So for this one, the IQRs or interquartile ranges are also equal. So because of this, I cannot compare consistency because the consistency is the same for both. They both have the same range and the same interquartile range. Now let's look at the next box plot, which shows the minutes per class that two students studied. So we're comparing Ryan and Tony. So let's compare the median for both. When I look at Ryan's median, it's right here at 24. And when I look at Tony's median, it's right here at 22. So since Ryan has a greater median, I can say that he typically studies more than Tony. So I'm going to say Ryan's median is greater, which means he typically studies more than Tony. Now for range, when I look at Ryan, his least value looks like it's right here around 12, and his greatest value looks like it's right here at 31. So to find his range, we're going to do 31 minus 12, which gives us a range of 19. For Tony, Tony's greatest value is right here at 33, and his least value is right here at 11. So his range is 33 minus 11, which would give us a range of 22. Now, since this is a measure of spread, since Tony's range is greater, that actually means that his data is less consistent because it is much more spread out. So I would say for this, my comparison would be that Tony's range is greater, which means his data is actually less consistent. Because when we're talking about measures of spread like range, interquartile range, and even mean absolute deviation, these are telling us about the consistency of the data. When a data set is closer together, that means that it is more consistent and more predictable. Now let's look at our interquartile ranges. When I look at Ryan's first quartile, I can see that it's right here at about 16. His third quartile is right here at about 28. So his interquartile range is going to be 28 minus 16, which gives me an interquartile range of 12. For Tony, his third quartile is right here at 26, and his first quartile is right here at 14. So his interquartile range is going to be 26 minus 14, which gives us an interquartile range of 12. So for this one, their interquartile ranges are equal. What we need to remember for this is that when we are looking at box plots and we are making comparisons of data, the one thing that I want you to remember is that when we say compare data, that doesn't mean find just where are they similar. In math, when we say compare data, that's telling me what do they have in common, but also what is different. So really, it means compare and contrast, even though it doesn't say that. When you're looking at data to compare in a box plot, I want you to always remember, and you can write this on the bottom of your page, the median is going to describe your typical performance. And then the IQR, so your interquartile and range, these describe consistency. When we're looking at these, you typically want to use the interquartile range as a best measure to describe consistency. It's usually more reliable than the range. But in both of the examples that you have interquartile ranges that are the same. So in those cases, you wouldn't be able to compare them based on interquartile range. So that's why we would move to then comparing their spread based on the range.